The topic of what existed before the huge explosion has ignited interest and discussion for quite a while. It is a major mystery, not just about how we comprehend the universe, but also about the limitations of human knowledge. Imagine standing on the edge of whatever is on the mind of thinking itself. What was there before the universe began? The Big Bang marks the beginning of everything we know: time, space, and matter. However, was there something before it? Could there have been a time before this mind-boggling event? And if so, what was it like? As we explore this question, science takes us on a journey into ideas that challenge what we assume we know. Popular physicist Brian Cox, known for explaining the wonders of the universe, proposes that something extraordinary could have existed before the Big Bang. He asks us to think differently about reality and existence. In this discussion, we'll break down the science and ideas that could help us understand what preceded everything we know. We'll examine theories about quantum changes, dark energy, and even the possibility of multiple universes. The answers might astonish you and could fundamentally change how we understand our place in the universe. The Big Bang and the mystery before it. To comprehend what existed before the Big Bang, we first need to understand what the Big Bang actually was. Scientists say the Big Bang was the moment when the universe became incredibly hot and dense, expanding rapidly and initiating the development of matter and energy. When we observe the stars and galaxies today, we see signs of that hot beginning as galaxies spread out from a starting point. But why did this happen? Was there anything before this hot start? According to the theory of cosmic inflation, before the Big Bang, the universe was cold, empty, and void. However, this emptiness wasn't completely devoid of energy. It contained a tremendous amount of energy that caused the rapid expansion of space itself. This rapid expansion, called inflation, happened so quickly that it set the stage for everything that came after. When this expansion slowed down, the energy transformed into matter and the forces we now observe as the Big Bang. The inflationary multiverse. Where did this energy come from, and why did it suddenly create the universe? Some scientists believe that this inflation created patches of the universe, each with its own Big Bang. Imagine a fabric stretching endlessly, with bubbles forming here and there, each bubble representing a different universe, including our own. This idea, called the inflationary multiverse, suggests there could be a limitless number of Big Bangs and universes. Our universe is just one of many. This epic idea challenges how we think about the universe and raises the question, what else is out there? The concept of nothingness. The notion of nothingness before the Big Bang is speculative. Even if you removed all energy, particles, and radiation, the universe would still not be completely empty. Space is filled with dark matter, dark energy, and quantum fields, forces and energies that make up the fabric of everything. Even in empty space, there is a strange form of energy called zero-point energy, which is the lowest possible energy level of quantum fields. At this state, particles can spontaneously appear and vanish, creating motion even in what should be empty space. This challenges our concept of nothingness and suggests that before the Big Bang, there may have been something scientists are still trying to understand. Cyclic cosmology. Another fascinating idea is cyclic cosmology, which offers a different perspective on the Big Bang. Instead of seeing it as a one-time event, this theory suggests that the universe goes through infinite cycles of birth, death, and rebirth. In this view, the Big Bang is not the beginning but part of an eternal cycle where universes expand, collapse, and are reborn. This theory implies that time might not be linear, but rather cyclical. If true, it suggests that what existed before the Big Bang was simply another version of the universe, one that ended and gave rise to ours. Gravitational waves and clues to the past. Gravitational waves, predicted by Einstein's theory of general relativity and later detected, could help us understand what happened before the Big Bang. These waves are ripples in the fabric of space-time, and they might allow us to look further back in time than ever before, possibly even beyond the Big Bang. Scientists hope that gravitational waves could provide evidence of events or conditions that existed before our universe began, pushing the boundaries of what we know about time and existence. Quantum fields and virtual particles. Quantum field theory suggests that the universe is not merely a collection of matter floating in space, but an intricate web of energy fields interacting to create everything we see. These fields are like invisible oceans, with particles acting as waves or disturbances within them. Even when these fields are at their lowest energy level, called the vacuum state, they remain active. Particles can spontaneously appear and disappear in these fields, borrowing energy momentarily and then returning it. These fleeting entities, known as virtual particles, challenge our idea of a completely empty void. This constant motion within the field suggests that the universe might not recognize our concept of nothing. The presence of such dynamic fields implies that even before the Big Bang, the universe could have been filled with these quantum fluctuations. Could this be the source of everything? If so, it forces us to rethink the origins of our universe and how something could emerge from what we perceive as nothing. Dark energy, a force before the Big Bang? Dark energy is a mysterious force driving the accelerated expansion of the universe. Could it have existed before the Big Bang? Some scientists hypothesize that the dark energy we observe today may be leftover energy from before our universe began. The properties of dark energy suggest a powerful force that may have played a role in the rapid expansion of space during inflation. If dark energy existed in a stronger form before the Big Bang, it might have created the conditions necessary for the formation of our universe. This idea raises profound questions. Could dark energy be a bridge to understanding a multiverse? Could it explain why the universe expanded so rapidly at its birth? These possibilities suggest that dark energy is not just a force shaping our universe, but also a key to unlocking the secrets of the cosmos. Eternal inflation and the multiverse. The theory of eternal inflation proposes that inflation never completely stops. Instead, it continues in some regions, creating countless new universes. Each Big Bang could be the spark that starts a new universe, while inflation continues in other areas, producing an endless number of universes. Imagine an infinite cosmic landscape, with universes being born like bubbles in a boiling pot of water. In this view, our universe is just one small bubble in a vast, eternal multiverse. Each bubble universe could have its own unique laws of physics, differing from ours in fundamental ways. This idea challenges our understanding of beginnings and endings. If inflation is eternal, there is no true beginning or end, only an endless cycle of creation. For scientists, this concept is both exciting and unsettling, as it suggests that our universe is just a tiny part of a much larger, infinite structure. Gravitational waves as a cosmic time machine. Gravitational waves offer a unique opportunity to explore what happened before the Big Bang. These ripples in space-time could carry information about events or conditions that existed before our universe began. By studying these waves, scientists hope to uncover clues about the nature of the cosmos before the Big Bang. For example, if another universe existed before ours, its collapse or interactions might have left detectable traces in the gravitational waves we observe today. Such discoveries could revolutionize our understanding of time and space, revealing a hidden history that stretches beyond the boundaries of our universe. The edge of understanding. As we delve deeper into the mysteries of what came before the Big Bang, we are confronted with the limits of human knowledge. These questions challenge our most fundamental assumptions about reality, time, and existence. Whether through quantum fields, dark energy, or the multiverse, science is pushing the boundaries of what we know. While we may not yet have definitive answers, the exploration itself is a testament to human curiosity and imagination. By questioning the origins of the universe, we are not only seeking to understand where we come from, but also redefining our place in the cosmos. The journey to uncover the secrets of what existed before the Big Bang is far from over. It is a path filled with wonder, uncertainty, and endless possibilities. A journey into the unknown, where the answers may one day change everything we know about the universe and ourselves. of logical revelation. The secrets remain, and what we realize now may be simply a little piece of what will be uncovered as we keep pushing the limits of human understanding. However, the inquiry still stands. What genuinely existed prior to all that? The answer may be stranger and more complex than we ever imagined. As we continue exploring the origins of the universe and the possibilities of what preceded the Big Bang, we delve deeper into the realms of speculative science. While certain ideas challenge the limits of our understanding, others offer a new perspective on how the universe may have come to be. One thing remains clear: the nature of the universe is full of surprises, and its origins may be far more intricate than we can envision. One potential hypothesis suggests that the universe could have undergone cycles of expansion and contraction, as proposed by the idea of the Big Crunch. In this theory, the universe could eventually collapse in on itself, only to explode again in another Big Bang, restarting the cycle. This recurrent model implies that the universe may have no clear beginning or end, but rather exist in a perpetual cycle of rebirths, where each new cycle is a different version of the universe. As science advances, we may find answers to these profound questions. However, for now, the mystery of what existed before the Big Bang continues to intrigue and inspire. As we delve deeper into these mysteries, it is essential to understand that much of the exploration surrounding this idea remains highly theoretical. While we can observe the current structure of the universe and study its origins through the Big Bang, what truly happened before this event is still beyond our reach. This does not mean the pursuit is futile. Instead, the journey itself may reveal more about the fabric of reality than we could ever imagine. One of the most significant aspects of cosmology is the role of time itself. As we know, the Big Bang marks the beginning of time and space as we understand them. Thus, the very question of before becomes problematic. According to Einstein's theory of relativity, space and time are not separate entities, but part of a single interconnected fabric known as spacetime. This implies that asking what occurred before the Big Bang might be meaningless, because time itself may not have existed before that event. If time is tied to the birth of the universe, there could have been no before to speak of at all. The concept of before the Big Bang poses another paradox. In a universe where space and time were created simultaneously, how can we apply our ordinary understanding of past, present, and future? Could it be that time itself is cyclical or not bound to a linear progression? This leads us to view time as a dimension that could stretch, compress, reverse, and loop without a fixed beginning. Ideas like these challenge our human intuition, reminding us that the universe operates according to laws that transcend our everyday experiences and perceptions. In the search for answers, one hypothesis gaining traction among physicists is the notion of a quantum fluctuation as the origin of the universe. In quantum mechanics, particles can spontaneously appear and disappear from seemingly nothing, a process known as quantum fluctuations. Could the entire universe have emerged from such a fluctuation in a quantum field? This would suggest that the universe as we know it might have arisen from a nothingness that was not truly nothing at all, but a fluctuating quantum field. This view implies that even before the Big Bang, there might have been a kind of quantum void filled with potential energy, but not matter in the form we recognize today. Yet, there are even more speculative ideas that stretch our understanding. One theory posits that our universe may have originated from a cosmic bounce, a cyclical model where each Big Bang is a rebirth following the collapse of a previous universe. This model suggests that the universe undergoes an infinite series of contractions and expansions, where it continually collapses under gravity, then explodes again, starting a new cycle of growth. In this view, our current universe might have been preceded by another that collapsed into a singularity, only to give birth to the universe we observe today. This hypothesis draws upon ideas from string theory and quantum gravity, but also raises questions about what drives these cycles and how they could continue indefinitely. Intriguingly, as our observational instruments and technology improve, we may one day find indirect evidence that provides greater insight into these theoretical ideas. Projects like the James Webb Space Telescope are offering astronomers unprecedented views of the universe, capturing light from distant galaxies and revealing clues about the conditions of the early universe. By studying phenomena such as cosmic microwave background radiation, thought to be the afterglow of the Big Bang, scientists hope to learn more about the earliest moments after the event. In doing so, they may find evidence that could help us learn more about the universe's origins and even explore the question of what came before. There is also the tantalizing possibility that advanced physics, still in its infancy, will eventually uncover deeper layers of understanding. Theoretical physicists are working on theories that aim to unify quantum mechanics and general relativity, which could allow us to understand conditions before the Big Bang. For example, the theory of quantum gravity attempts to describe the behavior of space-time at microscopic scales, where both quantum effects and gravity are significant. If successful, these efforts could one day offer a complete picture of the universe's origins and allow us to explore its pre-Big Bang state. Some theories even entertain the idea that our universe might not be the only one, suggesting that we are just one among an infinite number of universes in a larger multiverse. In this view, each universe would have its own set of physical laws, constants, and properties. Our universe, with its particular arrangement of matter and energy, might simply be one of many in an endlessly expanding cosmic structure. This idea also leads to the possibility of parallel universes, where events unfold differently from what we experience in our universe. The concept of the multiverse could reshape our understanding of the Big Bang, suggesting that our universe is just one of countless others that have emerged through similar or entirely different processes. Despite the immense challenges of answering what existed before the Big Bang, the pursuit of knowledge continues to expand the horizon of human understanding. As scientists explore quantum mechanics, cosmology, and the fundamental forces of nature, the answers to these questions may eventually emerge. Whether we find evidence of a pre-Big Bang universe, uncover new insights into the nature of reality, or stumble upon entirely new concepts that challenge our understanding, one thing is certain. The mysteries of the universe are vast, and we have only begun to scratch the surface. While the question of what came before the Big Bang might never be fully answered in our lifetime, the pursuit itself highlights humanity's deepest curiosity, the drive to understand where we come from, what the universe is made of, and what forces govern existence itself. This quest for truth, no matter how elusive, will continue to push the boundaries of human thought and scientific discovery. This relentless quest for understanding not only reveals the mysteries of the universe, but also reflects the profound resilience of human curiosity. Every discovery, whether monumental or subtle, adds a new layer to our comprehension, challenging existing paradigms and inspiring further inquiry. The pursuit of what lies beyond our grasp is a defining feature of humanity, and the unanswered questions about the universe's origins stand as a testament to our collective ambition. As we forge ahead, tools like particle accelerators, advanced telescopes, and computational simulations enable us to probe deeper into the cosmos and unlock new possibilities. For example, by studying phenomena like black holes, gravitational waves, and quantum entanglement, scientists hope to bridge the gap between the very large and the very small, between cosmology and quantum physics. These efforts may eventually provide the missing pieces needed to develop a unified theory of everything, a framework that explains the fundamental nature of reality in its entirety. Such breakthroughs could transform not only our understanding of the universe, but also our relationship with it. If, for instance, the multiverse theory is confirmed, it could fundamentally alter our perception of existence, raising philosophical and existential questions about our place in the cosmos. Are we merely one instance in an infinite array of possibilities? What would it mean to interact or even coexist with other universes should they ever become accessible? The implications extend beyond science and philosophy into culture, art, and even spirituality. For centuries, humanity has grappled with questions of origin and meaning, often turning to myths, religions, and metaphysical frameworks to fill the gaps in knowledge. The discovery of what preceded the Big Bang, or what might lie beyond it, could reshape these narratives, providing new insights into the interconnectedness of existence and our role within it. Yet, with every answer, new questions arise. If the universe emerged from a quantum fluctuation or a cyclical model, what governs the mechanisms behind these processes? Are there limits to what we can observe or comprehend? Could there be dimensions or realms beyond our sensory perception, operating under entirely different laws of physics? Moreover, as science progresses, we may find that the answers to these questions require us to rethink our most basic assumptions about reality. Concepts like time, space, causality, and existence itself could take on entirely new meanings, challenging the frameworks through which we interpret the world. In doing so, we may be forced to confront the limitations of human cognition and accept that some aspects of the universe may forever remain elusive. Even so, the pursuit itself is a source of inspiration. It demonstrates that progress often lies not in finding definitive answers, but in the process of asking better questions. The journey to understand the universe, its origins, its structure, its ultimate fate, is a shared endeavor that unites humanity across generations, fostering collaboration, creativity, and a sense of wonder. As we stand on the threshold of discovery, peering into the vast unknown, we are reminded of the words of the late Carl Sagan. Somewhere, something incredible is waiting to be known. With each new insight, we move closer to uncovering the incredible, rewriting the story of the cosmos, and illuminating the profound mysteries that lie at the heart of existence.